Good day, everyone. Welcome back to my channel. This is part 6 of Arithmetic Sequences Practice Problem Series. We're going to answer problems on arithmetic sequence. In today's episode, we're going to answer a word problems. So let's start. For our first problem, find the 10th term of the sequence negative 37, negative 34, and negative 31, and so on. So we are asking to find the 10th term. So when we say 10th term, the denotation of this is a sub 10. So all we need to do is to list first the given. We have our a sub 1, that is our first term. Our common difference, if we subtract it, negative 34 minus negative 37, that would be 3. And this also 3, so the common difference is 3. So our n, or the value of our n, is 10 because we're going to find the 10th term, or a sub 10. So the value of our n is 10. Now, and for our solution, remember the formula for arithmetic sequence, which is a sub n is equal to a sub 1 plus quantity n minus 1 multiplied to d. So if you know the formula, we just need to plug in all the given that we have. I have, just look at this. Those are the givens that I plug in. So these are our givens, and I just plug them in. Now let's subtract 10 minus 1. So we have 9. So let's multiply 9 to 3 of 27. Now negative 37 plus 27 is negative 10. So therefore our final answer would be negative 10. Our 10th term is negative 10. For problem number 2, find the 16th term of an arithmetic sequence if a sub 1 is 8 and the common difference is 9. So we have our first term as 8 and common difference as negative 9. So same method, just like for number 1. Just list all the given that we have. Now, at first, it seems you may be confused, where do I get this, the value of 16 for n? That is because we're asked to find a sub 16, or the 16th term. So that's why we have 16 for the value of n. Now let's again recall ourselves with the formula. Substitute all the values that we have. The red numbers are corresponds to the given that I plug in. So let's start with 16 minus 1. That would be 15. 15 multiplied by negative 9. That would be negative 135. So 8 minus negative 135 is negative 127. As you can see, on my previous tutorial, I tell that if the common difference is negative, therefore the sequence is in descending order, meaning from highest to lowest, it has a decreasing value. So it's good. It's nice to know that 8 is greater than negative 127, because it should be less than, because it's in descending order. Okay, for problem number 3, if the third term of an arithmetic sequence is 13 and the ninth term is 37, what is the common difference? I have a unique way on how to answer this problem. In our given, let's identify the lowest term that is available in our given, and that is a sub 3. We will somehow change it and make it a sub k, or the lowest term possible, and that is equal to 13. Now for the last term, or the last term that is available, that is a sub n, which is in this case a sub 9, the ninth term, and that is equal to 37. Now to get the value of k and 9, because we'll be needing this in our formula, just get the subscript of the term that corresponds to them. So for our common difference, we're going to find our common difference. So again, use this formula to find the common difference. Wherein last term minus the lowest term available, minus the subscript of the last term, and minus the subscript of the over the subscript of the last term, minus the subscript of the lowest term. So now let's substitute the value. So a sub n for 37, that is it, this is it. A sub k for 13, this is it. 9 for a sub n, and 3 for a sub k. After that, 37 minus 13 is 24. 9 minus 3 is 6. 24 minus 6 divided by 6 is 4. So the common difference is 4. So let's move on to the next question. What is the arithmetic mean between negative 12 and 4? To answer this, let's illustrate the problem first. So we have 12, blank, and 4. We need to put a number here that would make this an arithmetic sequence. So how we do that? To do that, let's add the first term and let's add the extremes. I should say these are the extremes. The number or the terms at the very end. So negative 12 plus 4 then divided by 2. Negative 12 plus 4 is over 2 is equal to negative 4. So the answer here is negative 4. Now let's try an arithmetic mean problem again. Insert 4 arithmetic means between 38 and 98. So again, illustrate it and then mark what term the following are. So I have a sub 1, 2, 3, 4, 5, and 6. Now let's assign a sub k for our lowest term possible and our a sub n for the last term that's given. Now let's use the common difference formula that we used a while ago. So let's use this. A sub n minus a sub k over n minus k. That is 98 minus 38 over 6 minus 1. 98 minus 38 is 60. 6 minus 1 is 5. 60 divided by 5 is 12. Now, on the previous example, on the previous tutorial, I said that if the common difference is given and a term is given, to get the next term, we just add the common difference. So 38 plus 12 is 50. 50 plus 12 is 62. 62 plus 12 is 74. 74 plus 12 is 86. And 86 plus 12 is 98. So that's the answer, and that's how to answer number 5. Now let's go to problem number 6. Which term of the sequence 13, 6, negative 1 is negative 85? So we will find the n here. So we know that our first term is 13 and our common difference is negative 7 because negative 1 minus 6 is negative 7. 6 minus 13 is negative 7. Now, we don't have a value of n because the question wants us to find the value of n so that this 85 will correspond to a sub n. So we know that our last term, we can consider negative 85 as our last term. So now let's use again the formula, plug all the things that are in our given. Then let's multiply negative 7 first. So we have negative 7n plus 7. That would be 13 minus 7n plus 7. Combine like terms. Let's combine that. So we have negative 7n plus 20. Let's subtract 20 on both sides to eliminate this 20 here, eliminate this 20 here, and to single out 7n. So minus 20. So the answer is negative 105. Now negative 105 is equal to negative 7n. We only want the value of n. So let's isolate n by dividing both sides by negative 7. So negative 105 divided by 7 is equal to 15. So n is equal to 15. So for our answer, negative 85 is the 15th term. Now, number 7. The last term of an arithmetic sequence is negative 104. The common difference is 13, negative 13, and the number of terms is 13. What is the first term? This question is somehow similar to our previous one. Instead of finding the what number of term, the number of terms is given. That is 13. So n is equal to 7. But we don't have a sub 1. So now we're going to find a sub 1 here. Let's list all are given. We don't have a sub 1. But we have a common difference of negative 13. And the last term is 104. Negative 104. We know that this 104 is also the 13th term because the sequence tells us that there are 13 terms. So let's just substitute all the values that we have. So we have here 104, the value of our n, and the value of our d. I'm sorry I didn't color this red. I might somehow miss it. So let's subtract 13 and 1 first. So 13 minus 1 is 12. 12 times 13 is negative 156. So let's now add 156 on both sides. And let's get the value of a sub 1. So the value of a sub 1 is 52. The first term is 52. Number 8. How many odd numbers between 4 and 112? Now, since that it is odd number, it is in multiple of 2. So our common difference here is 2. Now, how many odd numbers? We will count all the odd numbers that between 4 and 112. Now, what is the odd number that is next to 4? That is 5. So this will be our a sub 1. 112 is not an odd number, so maybe the number before 112 is our a sub n. That is 111. So we have now our given a sub 1 is 5, common difference is 2, and last term is 111. We don't have value for n. Again, let's use the arithmetic sequence formula. Let's plug in all the values that we have. Again, we don't have value of n because n will determine the number of terms of this 5 to 111 sequence. So let's multiply 2. So we get 2n minus 2. Let's combine like terms. 5 minus 2 is equal to 3. Let's subtract 3 on both sides. No, let's add 3 on both sides, I should say. So that gives us 108. 108. I'm sorry. Let's subtract 3 on both sides. So cancel this out. 111 minus 3 is 108. Now let's divide both sides by 2. So n is equal to 54. So there are 54 odd numbers between 4 and 112. Now let's go to number 9. Let's see if we can answer this problem. How many terms are there in the sequence 1, 4, 7, 10, and 182? Again, if how many terms is the answer, then we need to find the value of n. We have our first term, our last term, and our common difference, but we don't have n. So let's use again the formula. Substitute all the value. Multiply 3. Get this. Combine like terms. 1 minus 3 is negative 2. Now let's add 2 on both sides. 684 plus 2. 682 plus 2 is 684. It's equal to 3n. Now let's divide both sides by 3. So n is equal to 228. So there are 228 terms in the sequence. Okay. Now for number 10, this is not yet the last number. So in arithmetic sequence, a sub 2 is equal to 9. A sub 8 is equal to 21. Find the first term and the common difference. So it's like the what we do in arithmetic mean. So let's use the given and let's solve for d first. Let's use this formula to compute d. So again, our a sub n will be 21 and our n is equal to 8. Our a sub k is 9 and our k is equal to 2. Okay, so 21 minus 9 is 12. 6 minus 2 is 6. 8 minus 2 is 6. And 12 divided by 6 is 2. Now let's use a sub 2 as our a sub n. So we just subtract 2 here. So 9 minus 2 is equal to 7. So our a sub 1 is equal to 7. So but if you want to formula, just make a sub 2 as a sub n and use our formula and we will get a sub 1 as 7 and d is equal to 2. Now problem number 11. So if x plus 6, 2x plus 1, and 4x minus 13 form an arithmetic sequence, find x and the fifth term. Okay, I'll just illustrate this like this so that we could find the fourth and the fifth term and we can find also the value of x. If it is an arithmetic sequence, it tells us that if we subtract this from this, we will get a certain value. And if we subtract this from this, that value is equal to each other. So we can equate them and we can get the value of x. So let's do it. 2x plus 1 minus x plus 6. So this will become 2x plus 1. We will change the sign of it. It will become negative x and negative 6. And then if we add it, we have negative 5. Eh, so we have x minus 5. So this is our first difference. Now if we use this, so 4x minus 13 minus 2x plus 1, this will become 4x minus 13 minus 2x minus 1. Okay, so this will become 2x minus 13 plus negative 13, negative 1, 14. So these two are equal. X minus 5 is equal to 2x minus 14. So let's transpose 2x on the other side. So x minus 2x, negative 5 on the other side, negative 14 plus 5. Negative x is equal to negative 9. Multiply by 1 both side. X is equal to, x is equal to, x is equal to 9. That's the value of our x. Now let's check. 9 plus 6 is 15. Then 9 times 2 is 9 times 2 is 18 plus 1 is 19. 9 times 4 is 36. Now 36 minus 13 is 23. So 23. Now let's check if it has a common difference. 19 minus 15 is 4. 23 minus 19 is also 4. So we need to add 4 here. 23 plus 4 is 27. 27 plus 4 is 31. So the answer is 31. And the fifth term is 31. And x is equal to 9. That's the answer for number 11. Now let's go to our final problem. There are 28 logs in the bottom layer of a file, logs 27 in the next layer, 26 in the next, and and so on to the top, which is one log. How many logs are there in the 15? So this is a sequence like this. If we write the sequence, we We'll write 28 at the bottom, 27, 26. Now we can say that the common difference of this is -1. So we have 28 as our first term and common difference -1. Now we will going to find a sub 15. So let's solve for this using arithmetic sequence formula. Substitute the values that we have. And 15 minus 1 is 14. Multiplied by -1 is -14. 28 minus 14 is 14. So a sub 15 is 14. So there are 14 logs at the 15 layer from the bottom. So that's all for today. Thank you for staying until here. So thank you for listening. Hope that you learned something from this tutorial. And I hope that you'll stay tuned and invite other students to like our channel and subscribe. So that's all for today. Goodbye and thank you.